capacitance and capacitor. Let this be a conductor. It is charged. Because of charge, there is potential on the surface of the conductor. Because of charge, there is potential. And with the increase in charge, potential of the conductor also increases. So with the increase in charge, potential also increases. If charge is doubled, potential also gets doubled. Means if this is 2 times, this is 2 times, means charge is directly proportional to potential, or potential is directly proportional to charge. Here potential means influence of this charge at that point. Q by V is a constant. Ratio of two quantities, two variables is a constant, means those two variables are, or those two quantities are directly proportional, like this. And this constant of proportionality is denoted by C, which is called capacitance of the conductor. So this conductor can hold some charge, it can store some charge, and it has no infinite capacity to hold charge. Means indefinitely this conductor cannot be charged. If we keep giving charge to this conductor, then there exists repulsion between like charges, and that repulsion increases. As a result, this surrounding medium, which is air is an insulator, this electric field, because of the charge, can break the insulating property of air. Once air loses insulating property, then there is leakage of charge. So we are trying to give charge, but there is leakage of charge. This leakage of charge happens only when dielectric property of air medium is lost. That can happen only when potential is very high, few million volts. Okay. Now, we are not happy with capacity of this conductor to hold charge. That is why we go to some arrangement which can store more charge, and that arrangement is called a capacitor. A capacitor has two metal sheets which are parallel to each other, then two terminals from those two sheets, and a suitable dielectric medium between the sheets. This is the dielectric medium. So this is dielectric, this is conductor, this is also conductor. So this arrangement is a capacitor. So circuit symbol of a capacitor is two lines, parallel lines. If it is a variable capacitor, then capacitor like this with an arrow. So this symbol represents variable. So this entire symbol represents variable capacitor. Depending on different types of capacitors, different symbols are used. Let us see that at the end of the topic. Okay. Now this is a capacitor. Two metal plates which are parallel to each other, and one of the plates should be connected to ground. If charge is given to the capacitor, means if charge is given to one of the plates, then equal and opposite charge is induced. That is why we write this as plus Q and this minus Q. Okay. Therefore, net charge in the capacitor is 0. Q net equal to 0. Always charge in a capacitor refers to charge on each plate, because net charge equal to 0. Because of positive charge on this plate, there is some electric field. Because of negative charge, there is some electric field. Corresponding to electric field, there is some potential. So we can say that there is some potential at some point or at any point. And we can also say that there is potential difference between these two plates. Potential difference is delta V. In this case, charge is stored at one of the plates, equal and opposite charge is induced. Therefore, this arrangement can hold charge. Students, I told you, charge always refers to charge on each plate. It is not total charge. Now, this arrangement can store charge. So, capacitor is an arrangement which is used to store charge. Store charge. Second, capacitor is an arrangement. It is a device used to store electrical energy. Electrical energy. So we can write these two, which is used to store charge, or the one which is used to store electrical energy. Now let us see why these two plates are used and why one of the plates is connected to ground. Now, action of capacitor. Let this be a conductor, a metal sheet, thin metal sheet. If the sheet is charged, then there is some potential. There is some potential at this point. There is some potential, some other potential on the surface of the conductor. So we cannot keep adding charge to the conductor, because when we keep adding charge, potential increases, repulsion between charges increases. The surrounding medium, which is air, is an insulator. The electric field, strong electric field by this charge can break dielectric property of the medium, dielectric property of air. If the electric field due to positive charge can break the insulating property of air, then there will be leakage of charge. We are trying to add charge, but there is leakage of charge. Means at equilibrium this can hold some charge, and we are not happy with capacity of this conductor. Let this be 1. 2. To increase capacity of this conductor, let us keep one more conductor next to this, identical conductor. If this is a sheet of charge like this, in this case there are two sheets. Here charge is given to one of the plates. If this plate is charged, then this positive will attract valence electrons or conduction electrons in this plate. Then few conduction electrons can come closer to this positive charge. That's because of attraction. The farthest side loses electrons, means it takes equal and opposite charge, that is positive. See, at this point P, there is influence of positive charge, positive potential. Let that potential be plus 40 volt. But this negative charge also has some influence at P. Let the influence of negative charge at P be minus 15 volt. So the resultant potential at P is 25 volt. Means due to the presence of second plate closer to first plate, the net potential is decreased. If potential decreases, means this conductor can accept some more charge. That in turn pulls few more electrons. That in turn decreases the potential. So an equilibrium is reached where these electrons experience zero net force, because force on these electrons due to this positive charge is in this direction. Force on these electrons due to this positive charge is in this direction. If these two are equal and opposite, then the net force equal to 0. That is the meaning of equilibrium. Okay. See, compared to first case, charge accumulation is more in the second case. But still, we are not happy with capacity of this arrangement. That is why third case, conductor, second conductor is connected to ground. The second conductor is connected to ground. Okay. Now in this case, if charge is given to one plate, then this positive can attract valence electrons, few valence electrons. The other side takes equal and opposite charge. in this case plus charge. This positive potential, this positive side will attract electrons from the ground. So from the ground, few electrons will come and neutralize these positive sides. If this becomes neutral, then these electrons are just attracted by this positive side. As a result, overall potential decreases. So we can add some more charge. If charge is added, again this will pull few more electrons. Always remember, this positive charge cannot attract all the valence electrons. It can just pull few valence electrons. See, charge accumulation is increased. This in turn attracts more electrons, in turn decreases potential of the positive charge. Now we can put some more charge. This attracts, this increased positive charge will attract more electrons. This in turn decreases the potential effect of positive charge. So in that sense, more charge can be put on this conductor. So this can hold more charge. Still, we are not happy with capacity of this arrangement. To increase the capacity further, these two are two metal plates. The second plate is connected to ground. A dielectric medium is placed between the sheets like this. Recall the theory of dielectrics. This is a molecule, spherically symmetric or symmetric molecule. Symmetric molecule means negative charge center coincides with positive charge center, just like center of mass, thereby dipole moment equal to 0. But when electric field is applied to the molecule, molecule is distorted because negative electron cloud experiences force against the external electric field, means in this direction, and the other side, which is positive, more positive, will experience force in the direction of the field. There is separation of charges. Two equal and opposite charges separated by small distance constitutes an electric dipole, and here electric dipole moment is not equal to 0. Means in the absence of electric field, there is no dipole moment. Because of electric field, dipole moment is created. Come to this. Because of positive charge, negative charge is induced on the other plate, only negative charge. Here both negative and positive because it is not connected to ground. Because of positive charge, negative charge is induced. At the same time, the electric field by positive and negative charges will polarize molecules. These are the polarized molecules, just like this. Minus, plus, minus, plus. Molecules are polarized. Let me show that by only few. So negative site is closer to positive and positive is closer to negative. Observe carefully. In induced dipole moment, this negative side is closer to positive, means this negative sign has negative charge density denoted by sigma minus, and this side has positive charge density sigma plus. Now, influence of positive plate is not only decreased by this negative but also decreased by negative charges of the polarized molecules. Again, effect of positive plate is decreased by not only negative plate but also negative charge density of the polarized molecules. As a result, potential of the arrangement decreases. If potential decreases means we can keep adding charges. We can put some more charge. As soon as we put charge, equal and opposite charge is induced on the other plate. That in turn polarizes molecules. This negative charge further decreases the influence of positive. So This continues till equilibrium is reached. Once the equilibrium is reached means everything is settled. That is the meaning of equilibrium. Okay. When everything is settled, then this plate will be in a position to hold maximum charge. So this arrangement is called a capacitor. So usually in a typical capacitor there are two metal plates, and gap between the metal plates is filled with a suitable dielectric. D for dielectric, metal plate, P, P. And to store charge, one of the plates should be connected to ground. So this is how a capacitor works. This is the reason why we use two identical conductors with dielectric and this ground connection. Let us derive an expression for capacitance of a parallel plate capacitor. This is a plate. This is second plate. These two are identical plates separated by some distance d. One of the plates is connected to ground. If charge is given to one plate, equal and opposite charge is induced. There is electric field between the plates. This electric field is uniform, but at the edges there is non-uniform electric field, and this non-uniform electric field can be neglected only when area of each plate is very large. As a result, over a large space we get uniform electric field. Let area of each plate be A, distance between the plates is D. In this derivation we are using Q equal to CV. Q equal to CV. Charge, V stands for potential difference between the plates. C is capacitance. C is capacitance of the capacitor. V is potential difference. Potential difference between the plates. First equation. Second equation. Since it is a plate which is charged, it is appropriate to consider surface charge density denoted by sigma. Sigma equal to charge by area. Third equation. Relation between electric field and potential. Electric field equal to minus dV by dR, or V by distance between the plates. Potential difference across these two plates is V. So minus dV is represented by V. dR, distance between those 2 points, is represented by D. So we are using these three equations with this diagram. Okay. Capacitance of a parallel plate capacitor, or derivation of C equal to epsilon naught A by D. Consider a parallel plate capacitor. Let A be the area of each plate and D be the distance between the plates. One of the plates is connected to ground and the other plate is charged. Due to induction, equal and opposite charge is induced on the plate which is connected to ground. These two are two metal plates. One of the plate is connected to ground. This is the ground symbol. Distance between these two plates is small d. And area of each plate is A. Because of charge on one plate, equal and opposite charge is induced. So let this be sigma plus surface charge density, and this is sigma minus. But magnitude of sigma plus is equal to magnitude of sigma minus. There is electric field between the plates. This is that uniform electric field. There are three regions. Region above positive plate, region between the plates, region below the negative plate. Okay. Now observe, in this region 1, let us call this 1. Because of positive plate, electric field at this point is away, means up. This is the electric field due to positive charge, E plus. Due to negative charge, electric field is towards. So this is electric field at this point due to negative charge. These two are equal and opposite, therefore resultant field is 0. Now at this point, because of negative charge, electric field is towards. Because of positive charge at this point, electric field is away. Because of positive, away. Because of negative, towards. Again, these two are equal and opposite, therefore resultant electric field is 0. Means there is no electric field above the positive plate and below the negative plate. Now in between the plates, because of positive charge, electric field at this point is away. So this is electric field due to negative charge. At that point, due to negative charge, this is electric field at this point due to positive charge. At this point, due to negative charge, electric field is towards. I am supposed to write this vector on this vector. So since it is not clearly visible, let me write this next to this. So this is electric field due to negative charge. These two electric fields are in the same direction, therefore resultant electric field is sum of these two. 0 electric field, 0 electric field, there is electric field. For large area of the plate, d square, unit of d square is meter square, which can be compared to area. For large area of the plate, non-uniform electric field at the edges can be neglected. And the electric field is uniform between the plates. Uniform electric field between the plates. Electric field above positive plate, that is region 1. In this region, electric field equal to, resultant electric field equal to sigma by 2 epsilon naught. This equation is from application of Gauss theorem. Recall, electric field due to thin sheet of charge is sigma by 2 epsilon naught. This is electric field due to positive charge. That is this. Minus electric field due to negative charge. Sigma by 2 epsilon naught equal to 0. Means there is no electric field above the conductor. Similarly, electric field below negative plate. Region 2. Region 2 is below negative plate. Here also resultant electric field is 0 because these two electric fields are equal and opposite. Therefore, field due to positive charge is equal and opposite to field due to negative charge. Now, resultant field between the plates. E equal to electric field due to positive charge plus electric field due to negative charge. Since these two electric fields are in the same direction, resultant magnitude of the resultant electric field is sigma by 2 epsilon naught plus sigma by 2 epsilon naught equal to sigma by epsilon naught. This is magnitude, sigma by epsilon naught. Half plus half is 1, where sigma is surface charge density and epsilon naught is absolute permittivity of free space. But sigma equal to charge by area and electric field equal to minus dV by dr. So in place of minus dV, write potential difference V divided by dr is distance between the plates. Let us substitute these two in this equation. Substituting above two equations means these two equations. In equation 1 gives, equation 1 is E equal to V by D. V by D equal to sigma is Q by A into 1 by epsilon naught. Q by V equal to epsilon naught A by D. But capacitance of the capacitor is C equal to Q by V. Here is Q by V, implies capacitance of parallel plate capacitor is equal to epsilon naught A by D. Epsilon naught A by D. So this is the capacitance of a parallel plate capacitor. This capacitance depends on area of each plate. If area increases means it can store more charge. Capacitance is inversely proportional to distance between the plates. Distance between the plates means with the increase in separation between the plates, influence of one plate on the other plate decreases. Means capacity decreases. That is the meaning. C depends on area, C depends on distance between the plates. Probable questions. Mention the factors on which capacitance of a parallel plate capacitor depends. So you have to mention it depends on area and distance between the plates. 1 mark. How capacitance of a parallel plate capacitor does depend on area of each plate? Isn't it? You mention this and also write in statement. Capacitance is directly proportional to area of each plate. How does capacitance of a parallel plate capacitor does depend on distance between the plate? isn't it? 1 mark. 1 mark. Mention an expression for electric field between plates of a charged parallel plate capacitor. So electric field equal to sigma by epsilon naught. This we have seen in the derivation. It is due to two plates. 1 mark. Capacitance of parallel plate capacitor is C. What is the capacitance if distance between the plates is doubled and area of each plate is halved? So this is for 2 marks. It can also be asked for 1 mark if it is only answer. Capacitance of parallel plate capacitor is C. What is the capacitance if distance between the plates is halved and area of each plate is doubled? This is also for 1 or 2 marks. For this, answer should be C dash equal to distance between the plates is halved, area of each plate is doubled, means 4 times C. In this case, answer should be capacitance distance between the plates is doubled, area of each plate is halved. C dash equal to C by 4. Derive an expression for capacitance of parallel plate capacitor with air core. Means nothing in between the plates. This is for 3 or 4 or 5 marks. Copy these questions and answer.